Hello, in this video we're going to be talking about the third and fourth properties of water. So let's not waste any of your time, let's get right to it. When we're talking properties of water, again we want to identify the fact that it's hydrogen bonds that enable all of these properties. And you can see the hydrogen bonds if you look at the diagram. The big red ones, that's oxygen, and the little white ones, that's hydrogen. The hydrogens are bonded to the atoms, the oxygen atoms of another molecule. So in this episode, the properties that we're going to talk about that are super important, the third one is that water molecules are less dense as a solid than they are as a liquid. And that is very unique to water. You try anything else, you could take anything to the extreme. You take a car and melt it down to where it's a big old liquid, okay, get it hot enough where everything melts down and you've got this big old tub of liquid car, and you set another car, the same type of car, in it, it's going to sink. Okay, you take rocks, take a bunch of rocks, melt them down to where they're liquid like a volcano does, and then put other rocks in there and it's going to sink. No matter what you try, what you look for, what you use, the solid will always sink in the liquid except for water. And that's pretty amazing. Ice floats. We know that. We see that every day. We use ice in our drinks all the time, whatever the drinks may be. Pop at Pete's, like me, whatever. And that's super important, because now think about farm ponds. Think about rivers and streams. If the ice sunk, okay, the ice formed on the top and then sunk, trapping all the plants and the fish below, or the marine life below, what would happen? Yeah, they would die. Okay, just think about the penguin videos that you've watched, or the polar bear videos when they're out there hunting for fish and they've got to break the ice to get the fish. If all that ice sunk, okay, it would trap all those fish and kill them, and that would have a huge effect. So this property of water, the fact that the solid floats in the liquid, is simply amazing. Okay, our fourth property is the fact that water is an incredible solvent. Okay, that's why things dissolve in it. You're making tea, you're making lemonade, you're making coffee. You may have some grounds in the bottom, okay, because there's not enough water to dissolve them all, sugar, salt, whatever. But for the most part, water dissolves things. And when we think about dissolving, we can see it disappear, but what we can't see is really what's happening and the reason why it disappears. Okay, in our diagram here, we've got what used to be a salt molecule. The chlorine and the sodium together make salt. Water comes in and essentially bonds to those elements and replaces the previous bonds. In that case, it would have been an ionic bond. But it bonds to them and separates them. Okay, so when you see those molecules disappear, what's really happening is they're being separated, and what was the object now no longer exists, because there's no more salt in there. Okay, you have the flavoring still, which is a whole different concept, and maybe that's even more than I can understand. But it's the idea of the salt no longer exists because the bond has been broken and it doesn't have the materials needed. So when we think about a solvent, okay, and how that leads to a solution, okay, so water would be the solvent, and if you've had a chemistry class and you've talked all about solutions and what makes them up, but in a solution, you're going to have both the solvent, which is the liquid, and the solute, which are the minerals, okay, the elements, in this case sodium. would be the solute. Both of those together make up the solvent. But this particular property, number 4, is the fact that water is such a great solvent. Because it is, this is how cleaning products work. The water may not necessarily be able to bond with the dirt, because essentially when your clothes get cleaned, in the laundry or soap or whatever, essentially what's happening is a bond occurs, and then the dirt molecules are just dragged away when you rinse off your hands or wash your hands or whatever, a washing machine, a dishwasher, whatever. And so the water will bond to the cleaning agent, and the cleaning agent bonds to the dirt or whatever's trying to be cleaned, and that's how that is all pulled away. Okay, our next concept to consider is a part of these properties of water: adhesion, cohesion. Man, these are super, super important. You can see the water strider. He's demonstrating cohesion. You can see the beaker and the capillary tube. That's just showcasing adhesion. Where you can really see these. Well, let me back up. I'm getting ahead of myself. The distinction is to recognize that there are bonds occurring, but the difference between the two words are what's being bonded together. In cohesion, the same elements or molecules are bonding together. In adhesion, different molecules. So the way to remember that is togetherness, same. Adhesion, different molecules. Now, cohesion would be, in this case, would be between water molecules, and that's what makes surface tension, because they're really bonding together. So the surface tension of water is there because of cohesion. And when we say surface tension, we mean how tightly the molecules are held together, which makes the top of water very strong. And you wouldn't think so, but that's why belly flops hurt. You're coming off the diving board or just the side of the pool, and you're flat, and that's why they hurt, because in essence you're hitting a solid object. You don't think of water as a solid object, but its surface tension makes it that way. That's why it actually even hurts if you're in a pool or a creek or whatever, bathing or bathtub, and you just slap down on top of the water. That also hurts because of the surface tension of water. It's why water striders can walk on top of the water. So in essence, if we could increase the surface tension of water, we all could walk on the tops of water. And how cool would that be? Adhesion, the second property we're looking at here, is the idea of different molecules bonding together to generate pressure so we can move upward against gravity. And you may be saying, how in the world can you do that? Plants do it all the time. Where's the water for a plant? In the soil. Okay, if you think about a tree that's 200 feet tall or even 40 feet tall, like the ones we have around here, it's got to get water from the soil up to those leaves on the very top. How's it do it? Adhesion. Okay, adhesion, the binding of molecules in order to create pressure to move upwards, okay, is the way that they get water from the soil up to those top leaves. You can see adhesion when it comes to, soda drinks in a cup with a straw. Okay, you go to Pete's, you go to Casey's, you get you a drink, you're driving around, you look down and there's a liquid pop or whatever you got on the top of your lid. That's because it's pressured. Adhesion moves up the straw and out the top. Now you might be thinking, well, I bet some of the carbonation pressure has something to do with that, and it does to some effect. But it's the idea of their bonding together. I mean, the pressure is there from the carbonation, but it can't work unless it's got a solid to push against, and that's the adhesion. That's that bond between those particular molecules. So that's our video covering the third and fourth properties of water. In our next video, we will be looking at the fifth and sixth properties of water. We'll see you then.